Hi everyone, I'm Priscilla Valan Assumptio from St. Ignatius College of Education, and I'm here to discuss about the mechanical properties of solids and fluids. First, let's see what are solids. Solid is one of the fundamental states of matter. They have definite mass, volume, and shape, and they also possess high density. The molecules in solids are so tightly packed, and thus they have least amount of kinetic energy and short intermolecular distance between them. Large amount of pressure is required to compress solids. Solids are rigid in structure, thus they do not flow. Fluids. After solids, as we know, liquids and gases are the fundamental states of matter. So fluids comprise of both liquids and gases. Fluids don't possess a definite volume or shape. Since their molecules aren't tightly packed, they have the tendency to flow. As we have learnt before, fluids can be liquids that occupy the space of the container. A fluid can also be a gas or other material that continuously changes its shape under an applied stress or external force. Water, air, blood, mercury, honey are some of the examples of fluids. Now let's see about the mechanical properties of solids, which elaborates about the characteristics of solids. Elasticity, plasticity, stress, strain, Hooke's law, ductility, and strength. They are the mechanical properties of solids. Elasticity. Elasticity is known as the property of a body to regain its original shape and size when the external force is removed. The maximum stress the body can withstand to regain its original form on removal of deforming force is known as elastic limit. Whereas in plasticity, the body acquires the deformed shape and does not regain its original form even after the removal of external force. Thus, they lose the property of elasticity, and this property of solids is known as plasticity. Stress. It is the ratio of the internal force F which is given to deform the body to a particular area A over which this force acts. In equilibrium, the force applied internally is equal in magnitude to the external force. In simple words, stress is the force applied per unit area. Sigma is equal to Fa, where sigma is the stress applied, F is the force applied, and A is the area of the force applied. SI unit of stress is Newton per square meter. Dimensional formula for stress is m L inverse T to the power minus 2. Next is types of stress. Normal stress. The restoring force per unit area perpendicular to the body surface is known as normal stress. It is of two types, tensile and compressive stress. Tensile stress is applied to stretch an object and compressive stress is applied to compress an object. Tangential stress is when the elastic restoring force or deforming force acts parallel to the surface area. It is also known as shear stress. Strain. It is the ratio of amount of deformation experienced by the body to the initial size of the body. In simple words, it is the ratio of the change in size or shape to the original size or shape. Since it is expressed in numbers, it does not have any dimensions. Types of strain. Longitudinal strain. The strain produced on the body is focused of the deforming force, which leads to change in only the length of the object. This is known as longitudinal strain, also known as tensile strain. Next is volumetric strain. In this type of strain, the deforming force leads to change in only the volume of the object, thus known as volumetric strain. Shear strain. Due to the tangential strain, an angle tilt is caused in the body known as shear strain. Hooke's law. As we know, this law is named after the scientist Robert Hooke. Hooke's law states that the stress developed is directly proportional to the strain produced in the object. In short, for small deformities, stress is directly proportional to strain. Where stress is equal to K into strain, where K is the constant of proportionality or modulus of elasticity. Why we use K is Hooke's law is only applicable to elastic bodies and does not apply to plasticity property of solids. Stress strain curve. The stress strain curve is a depiction of the Hooke's law. A curve is drawn between stress and strain, where stress is the x-axis, strain is the x-axis and stress is the y-axis. The curve shows an ideal situation of the mechanical properties of solids. Next is ductility. It is the ability or state of a material to change its shape without losing its strength or breaking. The materials can be deformed into thin wires, sheets, plates, etc. Example, gold and silver. Strength. It is the ability to withstand stress without fracture or distortion. Thus, a material with high strength and high ductility will have more toughness. Mechanical properties of fluids, which elaborates about the characteristics of fluids. They are pressure, viscosity, coefficient of viscosity, Stokes' law, and surface tension. Pressure. It is the thrust experienced per unit area of the surface of a liquid. The component of force acting normal to the area of the surface upon the area of the surface is termed as pressure. Pressure is equal to force by area. It is a scalar quantity. To measure the pressure exerted by the fluid, a piston is used. Viscosity. For liquids, it refers to the informal concept of thickness. Viscosity is the property of the fluid in which an internal frictional force is created when the fluid is in motion. In simple, it is the ratio of the shearing stress to the velocity gradient of the fluid. Viscosity is also called fluid friction. The viscous force directly depends on the area of the layer and the velocity gradient. Coefficient of viscosity. Coefficient of viscosity of a liquid is equal to the tangential force required to maintain a unit velocity gradient between two parallel layers of liquid, each of area unity. The viscosity of a fluid is the measure of its resistance to deformation. The SI unit of coefficient of viscosity is Newton's second per square meter. Dimensional formula of coefficient of viscosity is mL inverse T inverse. Stokes' law. Stokes' law is a mathematical equation that expresses the drag force resisting the fall of small spherical particles through a fluid medium. According to Stokes' law, the backward dragging force acting on a small spherical body of radius r moving with a velocity v through a viscous medium of coefficient of viscosity nu is given by F is equal to 6 pi nu rv, where nu is the viscosity of the fluid, r is the radius of the particle, v is the velocity of the particle, Fg is the drag force, and Fg is the gravitational force. Next is surface tension. Surface tension is the tendency of the liquid surface at rest to shrink into minimum surface possible, thus allowing the higher density sink and the lower density particles float. It is the property of the fluid in which the free surface of fluid at rest tends to have minimum area, and so it behaves like a stretched elastic membrane. The force acting per unit length on the liquid surface, being normal and parallel to the surface, is called the force of surface tension. The SI unit of surface tension is Nm inverse, and its dimensional formula is m T to the power minus 2. Thus is the mechanical properties of solids and fluids. Thank you.